All right, let's get some stuff down on notes for what we had done in class today. I got to make an announcement here prior to starting this, though. You see the top of the page, right up here, it says 1.1 mass. That should not say that. It should obviously say 4.1 classifying matter. So please take note of that when you're watching the rest of these slides. My apologies. So Unit 4, describing substances. 4.1, we're just going to classify the different types of matter that we have. All matter around us can be called one of two things. Either it's a mixture or it's a pure substance. A mixture is defined as anything that has a variable composition. So wood would be a mixture. Composition varies greatly by the type of tree. And if you take a piece of wood, you can see a ton of variability within it. You know, the different grain and the knots, so on and so forth. Soda is certainly a mixture. If we take a soda and we pour it into a glass, we can see the carbonation. So you can see the dissolved CO2 with the bubbles that are coming up. And there's other things inside of soda. You've got water and flavorings and phosphoric acid, and they're all mixed together. They're not chemically combined. They're mixed with one another. Air is a good example of something that's a mixture. We can look at the air today, and we notice that 78% of the air today is going to be nitrogen, and about 21% of the air today is oxygen, the actual stuff that we breathe. We have about 0.03% carbon dioxide. Carbon dioxide is CO2, our main greenhouse gas contributor. We don't want that number to go up too much. Argon counts for about 9%, very inert gas, something that doesn't react a whole lot. Actually, that should be 0.09%. If it's 9%, the world is going to be hurting Turkey. 0.09%. Sorry about that, everybody. And then other gases comprise about 0.07%. This is really, really different from the earlier. The composition of the air, the mixture that is our air, has changed over time. So over the billions of years that our Earth has been around, we've actually seen a different composition arise. We've seen a decrease in nitrogen. We've seen a decrease in carbon dioxide. And we've seen, obviously, an increase in oxygen gas, which allows us to exist here on this planet. So pure substances can be defined as either compounds or elements, and they always have the same composition. And now in the POGIL, we also referenced something called a molecule, and you will notice that there is a definitive difference between the word molecule and compound. Just to reiterate, this would be an example of a molecule, O2. It is not an example of a compound, so it does not equal a compound. A compound would be CO2. But what's interesting is CO2 is also a molecule. So at the end of the day, all molecules are compounds, but not all compounds are molecules. So keep that in mind. Water is an example of a pure substance, not tap water, but pure water, so your distilled water. Okay, it's just a bunch of different molecules of H2O that are all brought together. So we can call it a compound as well because it's got two different types of atoms. So it's always H2O, it is only H2O. Again, tap water, not a pure substance. It has dissolved minerals, there are pollutants inside of it, so we would call tap water a mixture. Gold. Now gold in its pure form as 24 karat gold, which I doubt this car is plated in its pure form is certainly an element, and thus it is a pure substance. However, not all gold is 24 karat gold. We have less karat gold, 14 karat gold for instance. And this type of gold would be a mixture, mixtures of other types of metals that get put together that reduce the pureness of the gold, that change its properties. Mercury is an element. Carbon dioxide would be an example of a compound and a molecule. And again, it would be a pure substance. So if I'm looking on my little page here, all four of the things that you see here can be classified as pure substances. The only phrase that I have on this page that would be a mixture would be right here, tap water. Okay, so let's get, I like the flow chart that I'm going to use here to kind of describe matter. And I'd like you to kind of draw this. I'm going to go through it quickly. So draw this in your book. This is what I'll start out on Monday with, just to recap. Hopefully we got a pretty good understanding of the hierarchy of matter. So everything is matter. It gets broken down into two separate things. It can either be a mixture or it can be a pure substance. We have different types of mixtures, homogeneous mixtures. A homogeneous mixture, a good example of that would be Kool-Aid or salt water. These, as the TED Ed video suggested, are called solutions. Very difficult to see any difference. You actually can't see any difference between the particles and the liquid. We also have other types of mixtures called heterogeneous mixtures. Heterogeneous mixture would be like Chex Mix. You just have a mixture of different things, real easy to see the difference. Wood would also be a heterogeneous mixture, as you can see the different types of grains inside of the wood. On the other side of our tree, we also have pure substances, elements, and compounds. So compounds, example of a compound would be like CO2 or H2O. An example of an element would be simply, which uses the concept of a boiling of a liquid substance to separate out that liquid substance from something else. So here's the gist of it, and again, you'll see this tomorrow. But inside this flask here, you've got two liquids. They have two different boiling points. So what you do is you start heating it up, and one of the liquids is going to come off first. I'll draw that with using an orange arrow. It'll come off first, while the other liquid will stay down here in the round bottom flask. That orange liquid that's coming off is then going to flow through this little sidearm tube here, and that sidearm tube is actually surrounded in a bath of cold water. That cold water will then condense the orange liquid. When it condenses, it turns back into its original liquid form and falls into a different receiving vessel. In this case, the diagram is showing water being the stuff that's flowing through the coil. So maybe you're trapping water in this Erlenmeyer flask too. You're purifying water. Maybe you're getting it away from some salt because it originally was salt water. This entire apparatus is called a distillation apparatus. Okay? Distillation apparatus. Solubility is another way that we can actually separate a mixture out. If you've got two solid substances, and one of them you know is soluble in water, and the other one you know is not. But you can't separate these things out by just like counting and pulling one of the particles away from the other, because there's just too many of them. Well, one thing you could do is you could take the mixture and you could toss it in water. One of the things would dissolve, the other would not, and then you could hopefully get the one that does dissolve away from the other by kind of filtering off the liquid stuff. And a fourth physical property we can use to separate mixtures is magnetism. If you have two compounds that are combined with each other, one's magnetic, the other isn't, we could easily use magnetism to pull one out. All right, and lastly, now we're not going to talk a lot about chemical reactions up until, I think, chapter 6 or 7, but it is important at this point to note that pure substances can also be separated from one another. The pure substance can be separated from itself. So let's think of water, for example. We can actually separate the atoms that make up water into their specific individual atoms. We do this by investigating the substance's chemical properties. A chemical property is different from a physical property. A chemical property is a property that describes the ability of a substance to change to another substance. There are really two main chemical properties. Substances have a certain type of reactivity. That's how reactive they are. If we take sodium metal and we put it into chlorine gas, like I've done in this flask in the picture, or I haven't done, but the picture is showing, we get a pretty very aggressive reaction. The result is actually table salt, NaCl. So very inert, very easy, non-harmful material. But we see the reaction between the sodium and the chlorine by themselves is quite violent. Okay, so we can take a look at that reactivity and we can describe a substance based upon it. The other chemical property that usually rears its head is flammability. We can describe substances based on their flammability as well. Helium gas is not flammable. Oxygen gas hydrogen gas is flammable. So if we have two unknown gases, we light a match to one and it does nothing, boom, it might be helium gas. If we light a match to the other and it explodes, boom, it might be hydrogen gas. Okay, so that is the chemical property there. All right, that is 4.1.